Okay, method for finding probabilities. There are two methods for finding the probabilities corresponding to the random variable x in a binomial distribution. So the two methods are first using the binomial probability formula. So first is by using a formula, and second is using the binomial probabilities table. Okay, first using a formula, second using table. Okay, method 1, using the formula. For a binomial experiment, the probability of exactly x successes in n trials is given by the binomial formula. So we need to use this formula to find the probability for binomial experiment. Probability random variable equal to value x equal NCX. C is the combination. Okay, NCX is a combination formula. P is probability of success, power x given value x, and Q is probability of failure, power n minus x. Okay, where n is number of trials, x is number of successes among n trials, and P probability of success in any one trials, and Q is probability of failure in any one trials. So we need to identify what is the value of n, x is given. Okay, value x is a random variable value. P, probability of success. Q is probability of failure. Examples. Compute the probabilities of x successes using the binomial formula given as n equals 6, x equals 3, p probability of success equal to 0.03. Okay, now put in the formula given in the earlier slide. Probability x equal 3 is n is 6, c 3 is value of x, then p is 0.03 power x power 3, and then q is 1 minus 0.03, which is 0.97 power n minus x. N minus x is 6 minus 3 equal 3. So answer, so you can use the calculator to calculate 6C3. So calculate all this, simplify, so answer should be 0.005. Okay, number 2, a survey found that 1 out of 5 Malaysians says he or she has visited a doctor in any given month. If 10 people are selected at random, find the probability that exactly 3 will have visited a doctor last month. So probability x equal to 3. Okay, find the probability that exactly 3 will have visited a doctor. So random variable x value equal 3. Exactly 3. Okay, equal using a binomial formula. N C3, n is 10. 3 is the x value, then p is the 1 out of 5. So this is probability of success. 1 out of 5 is 0.3, 0.2. Okay, power x power 3, and then q is 1 minus 0.2, 0.8 power n minus 3. 10 minus 3, 7. So calculate this, the answer is 0.2013. Okay, method number 2 is using the binomial probabilities table. So we can just use the table, binomial probabilities table, and refer to the table by looking at n size is 10 on the first column. Second column is x value is 6, and then the first row is p, probability 0.5. So p here refer to 0.5, and then we locate the value of the probabilities from p value and size and x equal to 6. So the answer is here. So the answer probability x equal to 6 given on this cell, which is 0.2051. Okay, now using binomial probability table, try to answer these examples. Number 1, compute the probability of X successes using the binomial table where n equal to 2, p equal to 0.30, and x less or equal 1. Okay, for x less or equal 1, we have probability p x is 0 plus probability p x equal 1. So from the table, find the column and row where n equal to 2, p is 0.3. Okay, and find values when x equal to 0 and x equal to 1. So you get the probability of x equal to 0 and then plus probability when x equal to 1. So the answer should be 0.9100. Okay, number 2, 25% of all VCR manufactured by a large electronics company are defective. So it means that P is 0.25. The quality control inspector randomly selects 3 VCRs from the production line. What is the probability that exactly one of these 3 VCRs is defective? So it means that probability when x equal to 1. Okay, so from the tables, find the probability when x equal to 1, n equal to 3, and p is 0.25. So the answer should be 0.4219. Okay, B, at least 2 of these VCRs are defective. Okay, now using table when n equal 3, so at least 2 are defective. It means that when x equal to 2 and probability when x equal to 3. So add up P2 plus P3. Okay, for n equal to 3 and for P is 0.25. Okay, add up, so the answer should be 0.1562. Mean and standard deviation of the binomial probability distribution. For binomial probability distribution, the mean mu is given by NP, where N is size of sample and P is probability of success. And standard deviation, sigma, is given by cert and time P time Q. Okay, P probability of success, Q probability of failure, N is sample size. For example, the statistical bulletin published by Metropolitan Life Insurance Company reported that 2% of all American births results in twins. It means that probability all American births results in twins is 0.002. If a random sample of 8,000 births is taken, find the mean. Okay, mean is from the earlier formula, mean probability, mean binomial probability distribution is given by NP. So N is 8,000, 8 times 0.002, which is 160. Okay, variance is NPQ. NPQ is 8,000 times 0.002 times Q. Q is 1 minus 0.002. So 8,000 times 0.02 times time 1 minus 0.002. Okay, so answer is 156.8. Standard deviation is root or square root of variance. So square root of 156.8 is 12.52. Okay, do also exercise 3. Again, I will give the answer later. Try to do it on your own first, either using table or using formula. Okay, let's do this exercise and I will give you the answer later for you to check whether you have got the correct calculation or a wrong calculation. So let's do this exercise on your own first. A burglar alarm system has 6 fail-safe components. The probability of each failing is 0.05. So it means that P is 0.05. Find these probabilities. exactly 3 will fail. So it means probability x equal 3. To use the formula, you can either use the formula or you can use value from table. Less than 2 will fail. Less than 2, it means probability x0, x equal to 1 and x equal to 2. None will fail, it means that probability x equal 0. Number 2, a survey from Teenage Research Unlimited found that 30% of teenage consumers receive their spending money from part-time jobs. If 5 teenagers are selected at random, find the probability that at least 3 of them will have part-time jobs. Okay, so now P is 0.3. Okay, if 5 teenagers are selected at random, mean n equal to 5, find the probability that at least 3 of them will have part-time jobs. At least 3, it means that 3 x equal to 3 plus x equal to 4 plus probability x equal to 5. So you can use either formula or using table. I will give the answer later. Okay, next is Poisson probability distribution. Earlier we have learned about binomial probability distribution. Okay, now Poisson probability distribution. So for Poisson probability distribution, it is a discrete probability distribution useful when n is large and p is small. So this is the features for using Poisson probability distribution. The independent variables occur over a specified intervals. So value of probability x equal to is given in the form of interval. The random variable x is the number of occurrences of the event in an interval. Okay, so meaning that the random variable x takes value of an interval. The interval can be time, distance, area, volume, or some similar units. So this is the value of random variable x can take up in the form of intervals. These are examples. Okay, examples of Poisson probability distribution event is such as the number of accidents that occur on a highway given during a 1 week period. A 1 week period is an interval. So the number of accidents occur during a 1 week period is a Poisson probability distribution event. The number of customers entering a grocery store during 1 hour interval. 1 hour interval is the event interval. Okay, number of customers is the random variable. The values of random variable is 1 hour interval. Okay, another example, the number of TV sets sold at a department store during a given week. A week is given on an interval form. Okay, random variable is number of television set. The number of typing errors per page. Page is an interval form. The number of typing errors is the random variable. Okay, this is also Poisson probability distribution. Okay, last one, a certain type of fabric made contains an average 0.5 defects per 100 yards. 100 yards is an interval. Okay, so type of fabric contains an average 0.5 defects. This is a random variable. Okay, requirements for Poisson distribution. So these are the requirements that need to be met by random variable x given Poisson distribution. First, the random variable x is the number of occurrences of an event over some intervals, taken x0, 1, 2, 3 and so on. The occurrences must be random. Next, the occurrences must be independent of each other. The value of x is independent of each other. The occurrences must be uniformly distributed. It means that we use the mean number of occurrences instead of exact numbers. Okay, method 1, using formula. The probability of x occurrences in an interval for Poisson probability distribution is given by this formula. Probability random variable x equal to value x is exponent exponent is a constant number given by 2.7183. Exponent power negative lambda, where lambda is mean number of occurrences in that interval. Normally, lambda is a parameter given for any sampling. Okay, exponent, again exponent power negative lambda time lambda power x over x factorial. Mean and standard deviation of the Poisson probability distribution. Mean for Poisson probability distribution is given by mu equal to lambda. Okay, lambda is the parameter, lambda is the mean of the distribution provided from the sampling. Okay, standard deviation sigma is given by set of lambda. Okay, where lambda mean number of occurrences in that interval. Examples: find probability x lambda using the Poisson formula for P when x is 5 and lambda is 4. So using formula probability for Poisson probability distribution where random variable equal to 5 is e power to negative lambda, which is 4, and then lambda power to x, which is 4 power 5 over x factorial, 5 factorial. So calculate this where e given by constant 2.7182. So calculate this, so answer is 0.1563. Number 2, if there are 200 typographical errors randomly distributed